Hey, I'm Dr. Nate Bosch, Director of the Lilly Center for Lakes and Streams, and today we're talking about the water cycle, and we're in a perfect spot to talk about the water cycle. We're by one of our 14 live stream sensor locations here throughout Kosciuszko County in northern Indiana. And the way these stream sensor locations work is it starts with a stream sensor. They use Doppler radar to look at particles as they pass over the sensor. These sensors sit down on the bottom of the stream. I happen to have a side looker here, which would sit on a bridge abutment along the side of the stream, looking into the water from the side angle. But the one behind me is sitting down at the bottom, but since it's under the ice, I'm going to show you this one instead. So we've got some sensors there, and those sensors are sending out Doppler signals, and it's bouncing back, and we're getting an indication of how fast the water is moving, how much water is moving. We're measuring water temperature, barometric pressure, lots of different things. There's then a cable that connects up here to the data logger system. The data logger system is really where a lot of the electronics work of our stream sensor technology. So all the data is coming in here, it's being stored here, and this is where the data then gets sent to our website, where you can go any time of the day or night and see exactly what's going on in the streams around our county. There's also a battery that's in there, and we have a solar panel up here, and so that's charging the battery, and so it continues collecting data even in the nighttime hours, as well as during several cloudy days like we might have here in Indiana in the wintertime, for example. All right, now we're down here closer to the stream channel, and we're going to talk a little bit more specifically about the water cycle. So I've got a diagram here in front of me. This is the same diagram that we use for a lot of our K-12 field trips in our community here, as we're encouraging our citizens to be more water literate in northern Indiana. So I want to point out some different parts of the diagram here. So first off, we've got precipitation. That could be in the form of rain, it could be in the form of snow. We've got water that's coming down to the surface of the ground. And then there's two different things that can happen to that water. It can either run off the surface. We can have surface runoff, where the water will directly get to a lake or a stream like we're by here today. You can also have infiltration, where the water will infiltrate into the soil. And then you can have percolation of water going to deeper layers of the soil, kind of like maybe you've used the word percolation with coffee as water moves through the coffee grounds. We then, once we have water in the water body itself, like a stream or a lake, we have evaporation. And evaporation, where the water goes from that liquid form back to a vapor form again and up into the atmosphere, maybe to condense in a cloud and come back again as precipitation, or maybe it stays there for a while. We also can have plants interact with the water cycle. And so as is pictured here, we have trees with their deep roots pulling water from deeper layers of soil up into the trunk, branches, out the leaves then as those tree leaves are doing photosynthesis, and that water then gets back into the atmosphere and again completes the cycle. Within the soil, we also have another sort of transition that water can take. It can run off the surface, it can percolate down deep, and when it's percolating down into the soil, it can either come through as a lateral flow or subsurface flow, we can call that, or it can go into some of those deeper aquifer or groundwater layers, and it can start to move through the groundwater, through those aquifers. And that can either recharge a stream like this or a lake back behind us, or water can move from the creek or the lake directly into those groundwater, those aquifer sources of water. Regardless of how the water is going, it's called a water cycle because it keeps cycling around. It's coming down, it's moving around in the landscape, and then it's going back up into the atmosphere once again. Let's now talk about these different changes in the water cycle, specifically with this creek that's right beside us. All right, let's focus in on the water cycle with this stream as an example. So here we're at Cherry Creek, which flows into Winona Lake, which is back behind us over there. And this stream is a great example of a lot of these different things that we've been talking about. First off, let's start with precipitation. You can see snow that's on the ground here, right around my feet, right? Coming from the atmosphere, from up high, from clouds, down to the water, or down to the ground surface. Now, because it's frozen, even if this snow starts to melt, we're not going to get infiltration into the soil. We're only going to have the surface runoff here in this particular case at this time of year. Same thing if we were to have rain at this time of the year. Since the ground's frozen, we're just going to have surface runoff. That surface runoff is going to move across the surface until it gets to a body of water, in an urban environment until it gets to a storm drain or a gutter or something like that, and then into a pipe, and then moving out towards a water body. As that water moves across the surface, it can pick up things. It can pick up sediments and nutrients, and those things can actually have some negative impacts then on downstream water bodies. If we were in warmer months of the year here in northern Indiana, we could have infiltration, and the water would actually go into the soil surface right here, and we could have percolation as it starts to go down to deeper layers of the soil. And that water then can still move into the stream. Rather than across the surface, it can move in from underneath the surface of the soil. We call that lateral flow or subsurface flow, where we're still charging up, we're recharging that stream, the water in that stream, but it's not across the surface, it's just under the surface. Sometimes we have tile drains or storm drains that can also move water just beneath the surface directly into our streams or in our lakes as well. And then that groundwater, those aquifers, that deep water can also come into our stream. We call that a gaining stream, where we have water coming from deep underground into the stream, or we can have a losing stream. We can have certain times of the year where the water table drops enough around the stream where the water is actually moving out of the stream into the groundwater and recharging the groundwater, and the stream water is starting to subside a little bit. We also have some trees around us here along the stream bank, and in warmer months when we have leaves on those deciduous trees, those trees would be pulling up water from those deeper soil layers into the trunk, and then into the branches, into the leaves, and then through photosynthesis, that water is going to be expelled through the leaves and up into the atmosphere. Another way that water moves from the ground level back up into the air around us. Obviously, that's not happening at this time of the year, although we have a few evergreen trees kind of spotted around here, and they can still be pulling up some water even in the winter months. The water cycle is always cycling. The same water that we see in this creek here running by us right now might be the water that we're drinking or brushing our teeth with in the future. We all have a vested interest in keeping this water clean. At the Lilly Center, our mission is to make our lakes and streams clean, healthy, safe, and beautiful. If you want to learn more about how you can help us with that, go to our website, lakes.grace.edu, and learn about some specific things that you can do to help keep our lakes and streams cleaner. It might just be the water that you're going to be drinking someday.